Good morning, everybody. How are you? So let me share my screen and let's start. You guys can hear me, right? So give us a thumbs up if you do. Thank you, Elias. Okay, thank you. So today's session is going to be about time series analysis. So what is time series analysis? So time series analysis studies like how a variable changes over time and through time, treating time as an independent variable in the measured value as the response. So it helps us understand patterns such as trend, seasonality, cycles, and noise in order to explain why the data behaves the way it does. So it uses time as a like independent variable, and it gives us an outcome like a prediction for the future, or it's a pattern to see the trend, the seasonality, the cycles, and the noises. So the main goal is to forecast future values by learning from the past time dependent behavior. In this tutorial, we're not gonna go deep in the forecasting modeling and creating the model, but how are we going to identify if the time series, and how do we do the time series? So it's commonly used for non-stationary data like economic indicators, weather data, stock price, retail sales. It means basically all the data we have these days has a time stamp, right? So if we have a timestamp on our data, it must be crucial to analyze the time series. We have to do time series because we can understand the trends. Well, when is our sales gonna go up? When is our sales gonna go down? I mean, if you have a store, for example, let's just say, like, if the price of some uh, item will go up, like in a holidays, like you need to stock that item before it gets sold out and you get a maximum profit. So this kind of outcomes and this kind of understanding comes with when we do the time series analysis. So this is one of the use cases for time series. So how do we analyze the time series? First, we have to collect the data, clean the data, and ensure the time index is correct. This is very crucial, guys. Like, you need to always. Hello, is there anyone speaking? Okay, must be an accident. Let's continue. So where were we? Yeah, you need to clean the data and ensure the time index is correct. Yes, this is very important when we work with time. The date formats has to be the same for like the whole data, because like we have to sort the data in date format. Like we need to understand in chronological order for the time to give us a good analysis. So we always like try to convert the time format to the same format for all your data in one data set. So then next you can plot the series over time to see the trend and the patterns. You can check stationary using rolling stats or ADF, which we are going to see in the next slides. Use diagnostic charts, decomposition to understand behaviors, build a forecasting model, and interpret the prediction. So what are the significance of time series? So time series is the backbone for prediction and forecasting analysis. Specific, I'm sorry, one moment, guys. Okay. So time series is a backbone for prediction and forecasting analysis specific to time-based problem statements. Significant includes reveal historical patterns such as trends, seasonality, and long-term cycles. It helps us compare current behavior with past pattern to understand what's normal or unusual. So, for example, let's take the same example as before. If you have a store and your sales value uh, goes up or like goes down without any reason for the past years, you have to analyze that why is my sales is going down, like what's the reason for this item is not being sold at this time of year. So you can understand what your analysis is giving you, and you can implement a solution for it. So this is also one of the use cases for the time series. It identifies factor influencing the variable across different time periods. It provides the foundation for forecasting, enabling informed planning and decision making. Like I said, you can make decisions on based on your analysis. So, what are the basic components of a time series? There are four basic components you can find when you do time series. The one is trend, seasonality, cyclic, and irregularity. So let's go in details on each of them. So what is trend? Trend is the overall long-term movement of the data, like if it's going upward or downward or it's just flat. Uh, does not repeat at a fixed interval. Does not repeat at a fixed interval. It can go up or down. Like it can do. It can go like in both directions. So it's not a fixed interval. It represents a long-term growth, decline, or stability. We can understand by seeing the graph or the plot that if it's a growth graph or if our data or our plot is declining or is it stable. So we can understand the data. Another one is a seasonality. Seasonality is a repeating pattern that occurs at a regular interval, like it's daily, monthly, yearly. It's caused by predictable behaviors like weekends, on holidays, like weather cycles. So the same example for this also for your shop. For example, if the sale is always spike on the weekends, so okay, I have a customer, a lot of customers got coming on the weekend. So you stock your products on the weekend, so you don't go all sold out. So you can make predictive decisions based on your data. So often looks like a bell curve or a wave that repeats. So we're going to see that on the demo as well. So the next one is cyclic. Cyclic is a long-term ups and downs that do not follow the fixed schedule. It's influenced by a broader factor like economy cycle, market condition, climate shift. It's more uncertain and harder to predict that seasonality. So seasonality you can know like when it's going up or down. It gives you like a seasonality. For example, on the weekends, if your sales is going up, on the weekdays if it goes down, this is seasonality. So you expect something to happen on the weekends, but in cyclic, it does not mean like it's a definitive interval. It might be different, so it's uncertain and it's harder to predict. It will be influenced in different factors like economic cycles, like as I showed you guys, like market condition and climate shift. So the next one is irregularity. So irregularity is random spikes or drops caused by unexpected events. These are like just random values you can find in your data. For example, if your sales is like 100, 200, 150 range, and all of a sudden it goes like 0 or like 1,000, it's a spike, right? So you need to discover what that is, so you can find your irregularities in your data. So short-lived and unpredictable. They're unpredictable because they might be a mistake or it might cause like it's unexpected event. So they are short-lived and unpredictable. It includes accidents, sensor errors, sudden shocks, and rare events. As I think you guys worked on the week zero challenge with sensors, right? So when you do your EDAs, I think you found an outliers or values that doesn't fit to the data. So that might be like sensor error. So that's one of irregularities. So let's see them in comparison the components of the time series. For the trend, the time interval is like it's no fixed interval. As I told you guys, like pattern duration, it's a long or short term. It can be long or short. The behavior in the nature, it's smooth upward, downward, or flat movement. So it's not definitive. The predictability is high, like direction is clear. If it's going upward, the concept and your prediction will be like it's going up the next month or the next week. So the predictability is high. So when we come to seasonality, it's a fixed interval, like it might be daily or monthly or yearly or quarterly. So it has a fixed interval. Pattern duration, when we talk about the pattern duration, it could be short term and repeats regularly. Behavior wise, regular swings up and down, stable pattern. You might not know, like for example, uh, your sales might go like very down in the summer and it goes up in the winter, or in the winter it might be down and in the summer it goes up. So it's also you don't know, regular swings is up or down. So predictability it's also good, so you can expect what to get on that season. When we talk about cyclic, there is no fixed interval for it. Pattern duration, long or short cycles. Behavior-wise, it could go up, down movements tied to an economic business cycle. So many things can trigger like cyclic. For example, if the economy goes down, like for example in Ethiopia, like when we let's give an example in our country. For example, if an oil or uh, yeah, oil or fuel increases, like our economy increases, right? So it's cyclical, not definitive fixed interval. So we don't know when to start. It's tied to an event or like a trigger. So the predictability is like medium or low. It's tied to some trigger. So we don't have a fixed time interval. Irregular and noises are like there are no fixed interval for them because they're just random and short-lived. Behavior-wise, there are sudden spikes or drop caused by unexpected event. The predictability is like very low to none. So next, we are going to see like the limitation of time series. What could we face when we do time series? Because everything has a flow. So we have to consider the following while conducting a time series analysis. Uh, they are very sensitive to missing values, like gaps in the timeline can break decomposition and forecasting model. So always you need to clean your data before doing a time series analysis because it can't fill up gaps. There are methods you can fill gaps like forward filling, interpolation, like we are going to see that on the demo. You need to fill the gaps, or you don't need like a missing data to do time series. So this is very important point in time series, and it assumes a linear relationship. Like many time series methods work best when patterns behavior is linear and predictable way, and it requires transformation steps like differencing, smoothing, scaling, and extra pre-processing efforts, and it mostly univariate. It's like the classical time series models usually handle only one variable at a time and limiting complexity. So what are the data types of time series? There are two major types of time series, stationary and non-stationary. So what is stationary? It has no trend, no seasonality, no long-term cycles. It's the perfect prediction tool. If our data is stationary, it will not have like trends or no seasonality if it goes smoothly. So you can predict the future like perfectly. But most datas are not stationary in nature-wise. If you consider like stock markets, it goes up and down like every single time. So most datas are not stationary. So the mean stays constant over time when you define stationary. The variance means the amount of fluctuation, also constant. Uh, the covariance relationship between the time points does not change with time. Easier to model and required by many forecasting methods. So stationary, like for the future wise, we are not going to go deep on the time series forecasting modeling, but when we do that, when time series forecasting model, the data has to be stationary. We need to converge the data to stationary for the models to accept and train and forecast for the future. So what is stationary? Like I showed you guys, that's opposite of the stationary. It shows trends, seasonality, like changing variance, mean and variance change over time. Most real data is non-stationary and needs transformation. Like I told you guys, like to become stationary. Since our model will learn on patterns, if it's the data is non-stationary, if it has trends, if it has outliers, irregularities, or in noise, it will tamper with our data. So we need to clean it and make sure like we give it a stationary data for the model to perform well. So how to tell if a time series is stationary or not? First, you have to plot the series. Like stationary data stays around a constant level, and non-stationary shows trend or patterns. So you can see also on the plot, as soon as you see the plot, oh, this data is stationary or not. Check rolling mean and standard deviation. If it's stable, the series is stationary. If it's drift, it's not. Uh, Look for trend seasonality. Their presence indicates non-stationary. Like if it has a trend or seasonality, if it goes up in one season and it goes down in one season, that's not a stationary data. It's non-stationary. So, and also there is a test called ADF test. If the p-value is less than 0.05, it's stationary. If the p-value is 0.05, it's non-stationary. So we're gonna see that in the demo so you can understand more. So for example, in this plot, you can see that the stationary one here, it's stable. The mean is, I'm not talking about the data, guys. Like we need to be clear on that. Like the data is not stable. That just the mean value. Like is it is is the data oscillate on the mean value? For example, if you have like 100, 150, like 200, is there a question? You guys can hear me, right? Biniam? Biniam, you raised your hand. Is that an accident or? Okay, let's continue. So I was saying, like for the stationary data, like we can see that if the data is oscillating between like in the mean value, when you see the non-stationary value, it goes upward, so it doesn't have like a constant mean value. The mean also changes. So final point on this, the difference between seasonality and cyclic. The period for the seasonality is fixed and known. It's a fixed interval, as I mentioned, like it could be 7 days, like within 12 months, or quarterly within 3 months. It could be weekly, but it's known. The period is like known, it's season. So when we come to cyclic, it's not fixed. It could be like within 2 years, or the data change within 10 years, but it's cyclic. It will repeat itself, but it's not fixed. So the duration usually within a year, seasonality, cyclic it could be like longer than a year. Like the trigger point could be for the seasonality, calendar driven, for example, weather, holiday, school terms. For cyclic, like I mentioned, like it could be economic or business cycles. So predictability is also high for seasonality, and the cyclic one is less. For example, like ice cream sales increase like every summer, right? So we know when to stock our products. When we come to cyclic, the economy goes through like boom and recession cycle again. So uh, any question on this, guys, before we move to the demo? Okay, Binia.
ያ እኔ ጥያቄዎች ነበሩኝ። ቅድም ዲኩፕለር ቴስት ማድረግ አለብን ማለት ነው። ኤዲኤ ያልከው ማለት ነው።
ADF.
ኤዲኤፍ ዲኩፕለር ኦግመንት ቴስት። እሱን ቴስት ከማድረጋችን በፊት ቪአይኤፍ እና መልቲኮላኒቲ ወይም አውቶ ኮሪሌሽን በስታቲስቲካል ሜጀርመንት ውስጥ ቴስት ማድረግ ይኖርብናል ማለት ነው። ታይም ሲሪየስ እንትኑን ከማድረጋችን በፊት ወይ በፓይተን ላይ እንደዚህ አይነት ነገሮች አሉት?
What do you mean, like ADF test is for the is it a stationary or not የሚለውን ፊግር አውት ለማድረግ
ቢፎር ቼኪንግ ኢዲኤፍ ሞስት ስታቲስቲካል ሜጀርመንት እና በኢኮኖሜትሪክ ሜጀርመንቶች ላይ እንትን ቪአይኤፍ ወይም ደግሞ ቫሪያንስ ኢንተርቫል ፋክተር እና መልቲኮላኒቲ አውቶ ኮሪሌሽን የሚሉ ነገሮችን ቴስት ማድረግ ይኖርብናል። ኮንሲስተንት ነው ወይ ዳታው ለሞዴሉ የሚለውን ቴስት ከማድረጋችን በፊት ወይም ደግሞ ስቴሽነሪነቱን ከማረጋገጣችን በፊት ማለት ነው፣ በኦግመንትድ ከመሄዳችን በፊት እና ለዛ እነኛን ነገሮች በዚህም አሁን ባልከም ሜቶዶች ሜጀር ማድረግ አለብን ነው የሚለው ለመጠየቅ ብቻ።
Okay, so you don't need that thing. Like the ADF will tell you like if the data is stationary or not. So we are also gonna see on the demo, like you do the decomposition for the model to accept it and train on the stationary data only. Then when it's finished, it will merge the trends, the seasonality, and gives us a full data. So we are gonna see on the demo. So no worries. Let's go to a demo. Okay, so I also put a markdown for you guys. You can read this on your when I share it to you guys. So first thing is first, we have to import our libraries, an ADF, the seasonal decompose, the matplotlib, the pandas. You are familiar with it already. So in this notebook, we'll simulate a simple monthly sales time series to keep things like reproducible and easy to run. So I've created just a random data for you guys, so you can you don't need a data to run it on your notebook when you test and experiment on the notebook. So this is just the creation of our data. I've created like 5 years of sales data, like with a random seed from 2018 to 2022. So this is our head, the data head. So we have 60 columns, and because like we have 12 months within a year, times 5, it's 60 columns. So first thing, visualizing time versus key features. First step in time series analysis, usually like you collect the data, what we did already, plot it against time to see the pattern, trend, seasonality, noise, and so let's plot and see. So this is the sales data. Like first, when you notice the data is like going upward, right? So it's going well. It's not decreasing. It's going upward. There is also seasonality. There is also like an upward, downward on the plot, but as you can see, it's going upward. So let's understand the data here. The plot shows like a clear upward trend in monthly sales from like 2018 to 2022. Although the value fluctuates like month to month, it's different from month to month. As you can see, it goes down, like it goes up, but the overall is, as you can see, it goes upward. So you can say that it's a growing demand or it's a good business expansion over time. seasonal or short-term variation, like visible as small peaks and dips. As you can see, like there's spikes and there's dips. So no major long-term decline, suggesting a stable performance. So like this is what you get when you see like the first, we didn't even do anything, but we just plot the sales and the date plot. So you can also understand what your data is telling you. So next, let's see the components of the time series: the trend, the seasonality, the cyclic, the irregular. And we will use the seasonal decompose to visualize these components. So let's go with over 12 period of months. So this is a sales value, as I showed you guys. This is a trend, as you can see. Trend is going up. This is where we decompose and divide like our data to trend, seasonal, and residual. So this is a trend. As you can see, guys, it's going upward. So it also picked up some seasonal data here. As you can see on the plot, like there is a residual data all over the place. So this is where you decompose. You can use the seasonal decompose of the sales and model additive. So let's interpret this plot so you can understand more. What we observe on the top plot, it's the original sales data. The second plot is a trend. The trend component captures a long-term direction. It shows consistent and smooth increase, indicating that the sales are growing steadily for the 5 years, as you can see. So we picked up a trend. Seasonal, the seasonal components repeats every 12 months, as you can see here. This is like 1 month, 1 year, so it picks up, it goes up. The seasonal component repeats every 12 months, showing the regular annual patterns. Sales are higher during a certain months and lower during others, confirming a stable and repeating seasonal cycle. So we can understand this from our data. So there is also residuals. Residual represent the random noise left after removing the trend and seasonality. So this is what the components of time series and how we see them. So what we observed from here is trend smooth long-term direction. So our data repeats yearly pattern and it has irregular noise and leftovers. So when we come to stationary versus non-stationary time series, stationary, as I mentioned, the mean is constant over time, not the data, just the mean of the data. Like the variance is also constant over time. The covariance also stable. There is no trend or seasonality. When we come to non-stationary, as I mentioned, it's an opposite of the above. Most real data has like never stationary, like so it's harder for our models to predict the future. So this is why we have to convert our data to stationary decomposite and do the modeling. So let's see the rolling statistic to check stationary like visually. As I mentioned, the mean and standard deviation are not constant. As you can see, like the rolling mean, the orange value is going up. So the mean is not stable, right? It should have been like a straight line, but it's going up. So this is not a stationary data. So you don't even need like the calculation for it. Like you can see the plot and know that if it's the data is stationary or not. As you can see, the rolling standard deviation also oscillates. It's not a straight line. So this is how you define like non-stationary from the plot side. Yeah, the description, you can read it also. So yeah, so this is the ADF test I was talking about. So the ADF test is a calculation to identify if our time series is stationary or not. So like I told you guys, the p-value here, the p-value is less than 0.05, it's stationary. If it's greater than 0.5, it's non-stationary. So as you can see, we calculated the ADF test for our data, and it gives us a p-value of 0.99. This is well above our data. So how can we interpret these values? Like the p-value is less than 0.5. It's, as you can see, like it's 0.99. So the p-value is much greater than 0.05. So the ADF statistic is 2.23 here. It's not more negative than any of the critical values. And also we can see here, there is another testing and identifying way. If these critical values, no, the ADF statistics is like more negative than these critical values, it's also non-stationary, as you can see here, guys. So you can also see the data and understand why the data is non-stationary. So first order of differencing, like I mentioned, you guys need to differentiate the data between the trend, the seasonality, and the stable one before doing any modeling for or future forecasting. So this is the original series. So the first differencing series after we do differencing here, what we're going to do is first we're gonna drop if there is like an empty values gaps on the data and do the difference. So first differencing series, as you can see, it gives us like a mean value. This is like a stable oscillating value between like 1 or 0. So this is the stationary data. The original sales data shows a strong upward trend from like 2018 to 2022 within a clean long-term growth and changing levels over time. This indicates the series is non-stationary. After the differencing, the trend is removed. The values now fluctuate around 0 with more stable variance. This makes series closer to stationary. So we can do our model for the future. As you can see here, it oscillates between like 0 and 1. So it becomes a stationary. So next, the rolling stat and ADF on the difference. When we plot after we do the differencing, as you can see, the mean value and the standard deviation is almost flat, right? It's better than the previous plot here. So it becomes stationary. This is why we do the differencing. So when we calculate the ADF test, as you can see here, it gives us like negative 4.93. It's more negative than these three values, right? So this is a stationary data. You can read on it here, put all the descriptions here. The ADF is like negative 4.94. The p-value is 0.00029. So this is definitely like less than 0.05. So this is a stationary data. And also since the ADF statistics is lower, more negative than all critical values, the p-value is far below 0.05. We reject the null hypothesis. So this is stationary data. So this is how you do the calculation and know if the data is stationary or not. So yeah, so to finalize the point, this is a pure trend, is going upward. Pure seasonality looks like this. It's a perfect seasonality. It goes up in one season, it goes down. Trend plus seasonality plot looks like this. It goes up, it goes down in some point, it goes up. So this is just the perfect example for the time series. So irregular noise or spikes, if we separate them, this is how they look like. So this is a perfect example for the time series. So let's see. I was talking about the missing data on the time series, right? So how would it affect the time series if we like, let's create a fake gap in our data here, and let's try to catch let's try to catch the error if it's happening. So when we run this code, the number of missing values become 5. So decomposition failed due to missing values. It gives us, it doesn't work on missing values. So we need to fill the data, or forward filling, or we can make it interpolate. So forward filling means if you have like 10 and there is gap in between and the next one is 15, you forward fill it. You fill the next one with 10. Interpolate means you can put the mean value in it, or you can drop the missing values to do the time series analysis. So make sure, guys, you don't have a missing value in your data before doing time series. So after we fill the missing values with interpolate and decompose it again, it will work fine, and it shows us like a perfect graph, and you can plot and understand your data. So this is it, guys, for the time series uh, analysis demo and class. If you have any question, please ask. I'm going to share the slides and the demo notebook as soon as we finish the session, so you can read on it. There is a description on it, and you can understand with the data, and you can read how the data is interpreted to understand more. So thank you, guys. So any question? Thank you. Okay, so okay, Alamayo.
Okay, thank you for your teaching. Uh, in week 0, we had a channel called resource, but in week 1 we hadn't that. Can you share this resource in a
Oh,
channel
okay,
or
so
something?
yeah. So there was a resource called, there is a Slack group called Resource on week 0. So we
Yeah.
will try to create it on Slack, but you guys always have to check your Google Drive. I think
Okay.
it's always shared on the first day of the challenge, right? On the week, you guys have a Google Drive. So I will always put the datas, the demos, and everything relevant to our class there. So you should check that drive as soon as we finish the session. But we will try to create the Slack also.
Okay, thank you.
Thank you, Manuel. Okay. Enoch, you can continue.
Okay, thank you. My question is just, let's say for a fictional company with the sales data,
Okay.
it we might find that the sales over the weekend would be zero, mostly if this company does not work. So can we treat these zero
I'm
values, or
sorry, like can you repeat?
I was just saying, if we have a fictional company which
Okay.
just works for the dates between Monday to Friday, its sales
Okay.
record for the weekend would be zero. So can we treat these zero
Yeah.
values as they're going to be repeating as seasonal, or should we drop them out of our analysis?
Okay. So it depends on your need. So if you work on the weekdays, the weekend value, uh, you don't need the weekend value, right? Or you can put it like 0. So it knows the graph will go like up or down, and when it goes to the weekdays, it will be flat if you put the data there, or if you just ignore that weekend, you can work on the weekdays as data. So when I was talking about the missing data, for example, on the weekdays, if you miss like Wednesday or Thursday, it doesn't work. I was talking about that missing data, not, for example, there is a companies work on when you, for example, let's just imagine a school. It closes on the summer, right? So it will not have any data on the summer. So that's not the missing data. It's just the company data. So there is 0 on that. So 0 is also a value. I was talking about the non value. 0 is a data. So you can put 0 and work on your time series analysis. So it won't affect that. Did I answer your question, Enoch? Okay, great. Any other question, or should we end the session here? Okay, guys, thank you for attending. I will share the resources with you within a moment. Thank you for being here. Goodbye.